The role of a data scientist is now changing. Businesses no longer just want POC models in Jupyter notebooks because they provide zero business value. That's why, as data scientists, we now need to upskill ourselves in basic software engineering so that we can help the deployment process of our algorithms. So in this video, I want to break down all the key things we need to know from software engineering in order to be a really effective data scientist. Let's get into it. When building large applications, there are so many things to consider. Things like the backend, server, database, front end, APIs, and the algorithm itself if you're building a machine learning application. Key concepts like scalability, load balancing, caching, and the CAP theorem all need to be considered in order to build a really good and robust system. System design is really important for data scientists because it helps us understand exactly how our model will be used, so that way when we do build the model, we understand the inputs, the outputs, and how it's going to fit into the wider picture of the business. We essentially want our model to go into production as smoothly as possible, so we need to understand how the system works in order to achieve this. Now, you can take courses, watch videos on how system design works, but in my opinion, by far the most effective way is to essentially sit down with some software engineers and discuss how your model works in production. The best way to learn anything is through practice. And once you have hands-on experience walking through software engineers who've been doing these things for years, that will be way more valuable than simply just doing a course on system design. One tool that is very useful for canvassing and discussing system design is Miro, who are kindly sponsoring this video. Miro is an innovation workspace that allows teams to dream, design, and build the key concepts they need in order to implement their project. I personally use Miro for sprint planning, conducting retrospectives, and also scoping out work my team is planning on doing. Miro has plenty of templates for all these scenarios, so I don't need to worry about creating them from scratch. Miro also contains things like stick keys, voting, commenting, and emojis, which makes it even easier for collaboration. One tool that makes Miro incredibly effective is their advanced diagramming with AI feature. This allows me to create quick diagrams, flowcharts, and maps using a single prompt, expediting my workflow and increasing collaboration. For example, here is me writing a very basic prompt to generate an architecture to deploy a machine learning model. As you can see, the AI model takes in my prompt, spits out a very simple flowchart, giving me a good blueprint to start working from. I will leave a link in the description below for you to check out Miro and have a play with these AI features. Honestly, any tech professional should be competent using the command line because it's incredibly helpful. Navigating the terminal and executing commands are pretty much a necessity nowadays. I'm not saying that you need to be some sort of whiz in Nano or Vim, but you should have a really good grasp of the fundamentals of Unix systems and also how the file structure works, because a lot of servers and a lot of ways things are deployed using a Linux operating system. The reason you should learn command line, particularly the scripting languages of Bash and Z Shell, is because when you need to do things like Docker, Kubernetes, Git, or interact with a cloud provider locally, these things are incredibly important. I promise you that sometime in your data science career, you'll need to use the command line. So better to practice now for that occasion in the future. For some reason, data scientists are not taught how to write good, well-tested code. Instead, they focus on implementing machine learning models and doing some explanatory data analysis. Basically, all the fun stuff. I totally understand why this is the case, because it's a great way to introduce someone to the field and make them feel comfortable and kind of enjoy the process of learning data science. However, it is highly desirable to implement your machine learning algorithm using proper production code, because that's how you generate value for the business, which is ultimately what you're paid for as a data scientist. And a crucial component of this is being able to understand and know how to test your code really well. This includes writing unit tests, end-to-end tests, integration tests, and building CI/CD pipelines. Writing tests may not sound that fun, but it's tremendously vital because it ensures your code is doing exactly what you want it to do. I personally didn't like writing tests at the beginning, but over time I enjoy the process more, and I now understand exactly how important they are. AWS, Azure, and GCP are pretty much used by every single company nowadays. These three cloud providers are the de facto way of storing data and also deploying systems and your machine learning algorithms. Given how widespread these cloud systems are, it's very important that as data scientists, we have a really good understanding of how they work and some of their basic functionalities. Again, you don't need to be a fully fledged cloud engineer, but understanding how to do things like data storage, deploy systems, deploy your algorithm, how databases work, things like that are basically the fundamentals that will get you into most jobs, and it's kind of what most jobs require. AWS is the most popular one, and these are the things I recommend you learn. S3 and general file storage, EC2 and ECS instances, step functions and lambda functions, and things like Athena and general database tools. There is so much in this space that some people's jobs are literally to be AWS cloud engineers. So like I said, you don't need to learn everything, but just the key things I mentioned earlier. Testing is not the only thing you need to write high quality production code. Things like typing, formats and linters are also equally as important. Typing refers to the data types your variables take on, and also the input-output types of functions and classes. It's not actually typing on the keyboard, it's literally the type of variable that you'll have. As data scientists, we mainly use Python, and Python is inherently a dynamic language, which means it doesn't necessarily require us to type everything we do. However, through using things like MyPy to add typing to our programming really improves the way we debug it and also the readability of our code. Formatters are your code's best friend. What they do is they ensure your code is written in a way that adheres to general principles and guidelines, improving its readability. Linters are tools that catch minor bugs, formatting errors, and any odd design patterns that may impact or cause errors in your code. I'm not going to go into it here, but Python contains so many tools and packages that really help with all these three things I discussed. Just Google it and you'll find very obvious and simple examples of how you can apply formatting, linting, and typing into your code. If you want more data science advice like this, then make sure you check out my weekly newsletter, Dishing the Data. I send it every Monday morning, and it's all about my thoughts and experiences as a practicing data scientist. If that sounds interesting, I'll leave a link in the description below for you to check it out.